Hello, so today I'm going to talk about linear induction motors, a staple in roller coasters, and physics. What even is a linear induction motor? It's kind of in the same light as a linear synchronous motor, which I won't go in depth about, but people kind of compare them a lot as transportation related motors. They're used in roller coasters as a launching device, an alternative to chain lifts, cable lifts, and hydraulic launches. All of which generate some sort of motion. Like for chain lifts and cable lifts, they tend to bring the roller coaster cart to some sort of height, and then at that point they'll let gravity do the work. Whereas launches like hydraulic and linear synchronous motors and of course linear induction motors will do some sort of make some sort of force that causes it to be shot forward or backwards. And so yeah, it accelerates the coaster car as it goes over the motor. And linear induction motors can also act as a braking system, but usually they're used for launches. How does it even work? So there's fins. There's so basically there's a coaster cart, and of course people are riding it, right? And under the coaster cart there's some sort of fin. Usually it's a very some sort of aluminum or aluminum steel, something that's conductive. So the track carries one or two current carrying fins that are basically next to it. So when the cart rolls past them, there's some sort of interaction between the three fins. They're not touching, but they're interacting with each other. So yeah, there's a reaction, and so there's a stronger reaction as the more of the coaster fin, so more of the fin from the cart, actually goes within the area of the current carrying fins. And so, yes, there is a force created from that interaction, magnetic force. How does this actually relate to physics, anyway? So, there's current that generates in the track fins, it's connected to some power source. And so, that current generates a magnetic field. And from that, the magnetic field from the track creates some sort of magnetic flux. It increases or decreases magnetic flux, and that interacts with the train fin. When the conduction fin from the train moves between the plates, there's an induced magnetic field that creates an attractive force when entered. And then as it leaves, there's a repulsive force. And this can also work in reverse if you're trying to use as brakes. And all this works because of the relationship between current and magnetic field, Faraday's law and Lenz's law, as we learned in class. And here's a little video to show what's happening. So yeah, cool stuff. Nope, let's move on. So why are these linear induction motors chosen over other forms of force generation in roller coasters? So for one, provides a quick way of accelerating the carts. This creates a fun dynamic on the ride. Um, getting launched is thrilling, and it's different than traditional lift methods. So it's cool stuff. Reliability. So there's no mechanical contact between the track and the train. So if there was contact, it would produce wear over time. That would make it more susceptible to downtime. We don't like downtime. We want people to ride the ride, you know. And so, how is this compared to other devices? So, when comparing it to another big launching mechanism on roller coasters known as hydraulic launches, where hydraulic launches basically have a sort of wound up cable. They're using hydraulics for that, and it attaches to the bottom of the train. And what happens is it gets um, like it basically gets wound up and then it gets let go, so it slingshots the cart forward. And then if you've ever been to any sort of amusement park like Knott's Berry Farm where they have this kind of thing, you'll see they go really, really quickly because of that. Where linear induction motors, it takes a little bit for for them to accelerate. But yeah, not the one big thing. The one big thing about hydraulic launches though, that's a big no-no. Moving parts, rubbing parts. Um, there was a big incident like over a decade ago with Accelerator and Knott's Berry Farm where the cable snapped. Linear induction motors don't have to worry about cable snapping. Less risk and less wear in general, so less downtime. And then chain and cable lifts. The main comparison with that is of course linear induction motors are in like any sort of launch is very fun compared to a chain lift. I mean, just a different experience. But the big thing is that there's a lot less materials and space needed in order to accomplish the same gaining of speed that you need for the roller coaster to happen. And what I mean is like for chain and cable lifts, they need to be brought to a very big height, which requires a lot of support structure and a lot of track. Where these linear induction motors, as you can kind of see in this picture, it's just one long stretch. I mean, same with like any launches, but it's one long stretch before the ride like fully starts. So there's you can see the fins there, and that's how they'll interact with the roller coaster cart. But just one long stretch, and then the ride goes on. But yeah, that's overall the fun stuff about linear induction motors. Also know, of course, I mean, I'm using it in the context of roller coasters because roller coasters are pretty fun. But of course, there's very similar technology used in a lot of other transportation devices, as well as very comparable to like maglev trains and such. But it's cool to see it in the light of roller coasters. But yeah, thank you for watching. Thank you.